That one here. All right. So today we're going to talk about the quotient rule. All right. So if product rule is multiplication, what's quotient rule? Division. Good. So we're going to talk about what happens when we divide two functions today, and how that looks in a derivative. So let's just get started. If you ever see the phrase divided by in a problem, you are differentiating, then you must use the quotient rule. That's what goes out in the left-hand column. So divided by, or you recognize that it's division, or when you would say it, x squared divided by x, you know you're using the quotient rule. Okay. I'm going to purposely set this up so it looks just like what we did last week with the product rule. Okay, so I am actually going to ignore what they wrote there. Okay, so it is f prime of x times g of x minus f of x times g of x. I put too many parentheses, all over at g of x squared. I erased my extra parentheses. Oh, I missed a prime. It's g prime of x back here. If you do go work with somebody in BC, they're going to know a little saying for it. I'm not going to teach it yet. Okay. So, because I'm teaching this in a slightly different order, I'm twisting it in a different order than what I taught them. Okay. I think it's going to work for us. This product rule seems to be working so far. All right. So I'm going to use my red and my green again. All I'm using is red and green, no other colors today. Okay. So my red is my numerator, my f function. Okay. So I take the derivative of my red and I keep my red original. Same order it was in the product rule, right? Now I'm going to take my green. My green is my denominator. So I keep my green original. I take my green derivative, and then I take my green and I square it. The other big difference in here is you notice that it's a minus sign. See the minus sign in there? So the operation changes. If it's multiplication, it's an addition sign. If it's division, it's a minus sign. Okay. Sometimes that means, depending upon how far we simplify, sometimes you might want to watch extra parentheses back there because you may have to distribute a negative. I am not going to simplify a whole lot of them today. I'm not expecting you to simplify them on your homework. I just want you to get the quotient rule piece down. Okay. I'm going to simplify the first one and the last two. Okay. Everything else in between, I'm not going to. All right. So the first one is, that was my alarm to start the notes in case I got too busy with homework. So in case, I want you to believe that the quotient rule works. So I picked something really simple to start. Okay. We don't need the quotient rule for that. All right, and you'll notice I accidentally left divide or used the quotient rule in the instructions in the notes. I should have changed it to just differentiate the function. Okay, so I would make that change for your homework at least. So I don't write down anything yet. All right, I'm going to do this the other way, the short way first. So if I were to simplify that, wouldn't it be x cubed divided by x squared is just x? And then what's the derivative of that? 1. Okay, so now let's use the quotient rule, okay, to do the same thing. So now you're going to start writing. Okay, what's my red function? X cubed. So I'm underlining the red one, or the x cubed in red. What's my green function? X squared is my denominator. Okay. All right, so I'm going to go f prime of x equals, oh, that's not the right slide. Go back. F prime of x equals, I know I've got a division bar, right? So I take the derivative of my red, which is 3x squared. I keep my green one the way it looks. Instead, because we're in quotient rule, what operation do we use? Subtraction, good. And then I keep my red one the way it is. So x cubed, what's the derivative of my green one? 2x. And then I take my green one and I square it. So let's track what happens so you guys can see it when you go back to this for homework. So red derivative, red original. Green original, green derivative, green squared. Now, for your homework, that's where you would stop today. But I want you to believe me that this works. So I'm going to keep simplifying till I get to the 1. Okay? So keep going with this a little bit. What is x squared times x squared? So 3x to the 4th. What's x cubed times 2x? 2x to the 4th all over x to the 4th. What's 3x to the 4th minus 2x to the 4th? 1x to the 4th over x to the 4th is? Did the quotient rule work? Did we get what we got on when we simplified it the other way? Yes, so we believe the quotient rule and that it works. Okay, we're going to make them a little bit harder. All right, so looking at example 2, am I using the quotient rule?
Yes.
Why? You're dividing, so we got to use the quotient rule. All right, what is my red function? Good, so I'm underlining that in red. What's my green function? X squared plus 1. Awesome. All right, you already told me I'm using the quotient rule, so I'm setting up for that. All right, well, I take the derivative of my red. What's the derivative of my red? 2x, good. And then I keep my green the same, x squared plus 1. What operation in between? Minus, because we are doing quotient rule, okay? All right, I keep my red the same. And then what do I do? Derivative of the green, which is 2x. The only difference between product rule and quotient rule was I put a minus in there, right? Okay, at least within the numerator. And then what has to go on the denominator? Green function squared. Good. All right, I'm going to track what I did, but I'm not simplifying any more than that right now. So what am my red function derivative, red function original? Green original, green derivative, green squared. Okay. Yes, we could probably distribute some 2's. Yes, there's probably some simplifying to be done. No, I'm not doing any of it. Okay. So that's exactly what I want to see for your homework answers tonight is that. Okay. So don't worry about going further than that. All right, let's look at 3. Is 3 a quotient rule?
Yes.
Why?
There's a negative exponent.
That negative exponent's going to make that look like what?
A fraction.
A fraction. So thank you for not letting that trick you. So 2x minus 1 over x plus 4x plus 5. We don't know enough yet to actually use a product rule on that. We will soon, but we don't know enough yet to make that into a product rule. Okay. So we're going to call it a quotient rule. All right, what's my red function?
2x minus 1.
Good. So underlying 2x minus 1 in red. And then what's my green function?
4x.
Good. All right, so f prime of x equals. I know I'm using quotient rule, so I get out my big fraction bar. All right, derivative of the red is what? 2. Good. And then green original 4x plus 5. What operation? Subtraction. Okay, keep the red the way it is. What's the derivative of the green? 4. And then take the green and do what to it? Square it. All right, I'm going to go back and track what I did. So red derivative, red original. Green original, green derivative, green squared. All right, everybody got it? Okay. All right. Let's look at, okay. Let's look at this one here. So, what is your red function? 3. Good. What is your green function? Good. All right, so I'm going to start my derivative. So, derivative of the red is 0. Excellent. And then keep the green exactly the way it is. X squared plus 2x plus 1. What operation do I put in between? Subtraction. All right. I keep the red the way it is. What's the derivative of the green?
2x plus 2.
Good. And then what do I do on the bottom? Green squared. Let's go through and track it. So, red derivative, red original. Green original, green derivative, green squared. Okay, if I was to simplify it, what's going to happen to this first term here? Yeah, it's going to drop out, and really all I would have left is this, right? So hopefully you'd recognize that in a multiple choice answer. All right, I want you guys to try example 5 on your own. So everybody is trying 5. Okay, let's check it. So, what'd you do first? Derivative red, which is 3. Good. Okay, and then what? Keep the green. Okay, and then what did you do? Minus, and then what? Keep the red, and then what? Derivative green, which is? Good, and then what goes in the denominator? Green squared. All right, I'm going to go through and track it for you really quick. So, red derivative, red original. Green original, green derivative, green squared. Everybody good? Okay, there's a catch on the next one. Hopefully you didn't go too far. All right. So, notice out in the left-hand column, it says the quotient rule is not necessary for an equation divided by a number. So do you see how you have a function divided by a number? You can do the quotient rule on it, but you're wasting a lot of time because this is really saying 1/5 x cubed. Don't we know how to do that with the power rule? Yeah, so I'm just going to use the power rule on it. So I'm going to take the 3, bring it in front. So 3/5 x squared. Done. Okay. Again, I can use the quotient rule on it, but I don't have to. Okay, so I'm not going to do more work than I need to. All right, so the last 2 I kind of threw down there at the bottom because I wanted to make sure we got them in there today. We're going to prove the derivative of tangent and prove the derivative of secant because I just gave them to you last week, right? I said, hey, here they are. We couldn't prove them without the quotient rule. So I wanted you to be able to use them in the product rule. We weren't able to prove it yet. So we're going to prove them. So first thing is I'm going to do is I'm going to rewrite tangent. What's another name for tangent? Sine over cosine, or sine divided by cosine. So I'd have to use the product or the quotient rule to take the derivative. I'm just going to label it f prime for lack of anything better right now. All right, so what's my red function?
Sine x.
Sine x. What's my green function?
Cosine x.
Cosine x. Perfect. All right, we're going to follow the rules. So derivative red is
Cosine x.
cosine x. Keep the green, which is cosine x. What do I have to do now? Subtract. And so I keep the red the way it is, sine x. Around trig, we know always parentheses. What's the derivative of the green?
Sine x.
And then all over the green, squared. Good. I added this thing in and it made it worse. So I'm just going to take it back out. Okay. So I'm going to track what happened. I have red derivative, red original. Green original, green derivative, green squared. Now, we're trying to prove what the actual derivative of tangent is, which I gave you last week. So we do need to simplify this. So on this one and the next one, we are going to simplify. So what's cosine times cosine?
Cosine squared.
Cosine squared. Good. What's negative sine x times negative sine x?
Sine squared.
Positive sine squared x all over cosine squared x. Okay. What's cosine squared plus sine squared? Look up at the pink sign. It's equal to 1. Cosine squared x. What's 1 over cosine?
Secant.
So it is secant squared x. So our derivative of tangent every single time is secant squared. We just proved it. Okay. I think it's kind of nifty when we can actually see how they get from one to the other rather than just me giving it to you. Okay. The proof for cotangent is exactly the same, right? It's just going to end with cosecant squared. All right, you don't ever have to prove it again, but if you forgot the derivative of tangent, could you figure it out? Yeah, I wouldn't waste time doing that. I just memorize it, but it's possible. All right, let's look at secant. Okay, so secant, let's think back to our trig, is what's another name for secant?
1 over cosine.
1 over cosine, good. All right, so I'm going to start taking my derivative of that. What's my green function or my red function right now? 1, and then what's my green function?
Cosine x.
Cosine x. Okay, again, we're just going to follow the rules that we know. That's all I'm doing. So I know I'm using quotient rule because I've got divide. What's the derivative of the red?
0.
0. And then green the way it is. What operation goes in there?
Subtraction.
Subtraction. Okay, keep the red the way it is. What's the derivative of the green?
Negative sine x.
And remember, parentheses around trig always. And then all over the green, what? Squared. Good. All right, I'm going to track what I did. Derivative red, original red. Original green, derivative green, green squared. Oh, not time to spare. Okay. With 0 times cosine x, what's going to happen?
0.
0. They're gone. All right. -1 times negative sine x.
Positive sine x.
Positive sine x. So it's 1 sine x. Sorry, that got a little thing in there. Cosine x. I'm going to rewrite that as cosine x times cosine x. You'll see why in a second here. Erase that and fix it. All right. Let me split that into 2 separate fractions here so maybe we can see what goes on. So I've got 1 over cosine x times sine x over cosine x. What's 1 over cosine reduced to? Secant x, and then sine over cosine is tangent x. Last week I gave you that crazy thing, right? And you're going, this looks weird, but look at what it is when we actually take the derivative by the quotient rule. Derivative of secant, 100% of the time, is secant tangent. Okay? Again, if you didn't remember it, you could develop it. However, you're gonna have to use it enough that I would just get it memorized. Okay, but now you can see at least where it came from. Okay. All right. I believe I put a Power School worksheet up there.